Assalamualaikum and hello everyone. In this part, we'll learn how to represent a complex number on a graph, what we call the complex plane or Argand diagram. A complex number z equal to a plus bj can be represented as a point A, B in the XY plane, where the X axis shows the real part and the Y axis show the imaginary part. Let's look at this diagram. It's exactly like a normal Cartesian plane. The horizontal axis is the real axis and the vertical axis is the imaginary axis. So, if we have z equal to a plus bj, we plot the point at A and B. For example, if we have z equal to 4 plus 3j, it will be plotted at 4, 3. That's 4 unit along the real axis and 3 unit up the imaginary axis. Now let's see this visually using Desmos. I will treat the horizontal axis as the real part and the vertical axis as the imaginary part. So this is Desmos. In Desmos, we can plot a point by writing the x and the y. But for complex number, right, we can write it using the standard mode of complex number, the a plus bj, by enabling the complex mode. So let's try to key in one complex number. Let's try to do z equal to a 4 plus 3j. So we have z equal to 4 plus 3j. As you can see, it doesn't actually plot anything here, because actually for Desmos, the notation for complex number is actually I. So instead of j, let's use I. So as you can see now, the z equal 4 plus 3i is actually plotted in the graph. Let's try to refer to example 1.9. We will plot each of these numbers one by one. First, let's look at A. A is z equal to 15. So to label it in Desmos, right, if you just put z equal to 15, it will not treat it as a complex number. So what you need to do is actually you need to write a complete standard form. So basically 15 is the real part and we have to plus with the imaginary part, the non-existing imaginary part, which is actually 0i. Let's zoom in a bit so that we have it. That is where the plot of A. Next, let's do B. B is negative 7j. So we have Z equal to negative 7i. So for this case, we don't really need to write the full things because we already write the imaginary part. Desmos already trace it as a complex number form. So automatically it has the plot there. So let's proceed to C and D. So for C is negative 5 plus 9j. So so Z equal to negative 5 plus 9i. So I put a label over here, right? And lastly, we have negative 4 minus 5j. Negative 4 minus 5i. Let's put it set here. Equal to. Alright, so here's everything. Now let me exclude our initial example. So basically this is all the plots. Right, so in our subject, the way we will graphically represent the complex number on the Argand diagram is not just by plotting. Later on, we also need to connect it to the origin, which is 0, 0. Let's do it. Let's do that next. So this is the copy of the chart that we plot in Desmos. So sorry, but I don't really able to find on how to connect the dot to the origin. So let's try to do it manually. So basically what I said when I said we need to connect it to the origin, this is where you should connect it with the 0, 0. So right, sorry for the improper lining later, but this is actually how you draft it, right? So this is how it should be. Alright, so alright, so this is the line for 7i. Sorry, let me do it again. And the line for negative 4 minus 5i. So these are the 4 lines. Notice how these points and lines match the one in our textbook diagram. Each complex number corresponds to a unique point on the Argand diagram. Now let's see what happens when we add two complex numbers on the Argand diagram. So refer to exercise 1.3. So for this case, they are adding Z1 5 minus 2j and Z2 7 plus 3j. So adding these two will give you the answer of 12 plus 2j. So how will it look like in an Argand diagram? As you can see, the answer here, if we just plot z1 and z2 individually, this is where they should be, right? Without any, how can I say this, relationship whatsoever. But then when we do the addition, right, we can see the what actually the kind of relationship that being formed between these two complex numbers. So this is where the value of z1 plus z2, right, from the origin straight ahead. So we're still not learning this. This is actually kind of the shapes that we're going to learn in vector, which is called parallelogram, right? So as you can see, what happened here is that the kind of relationship that we have here is it gives the diagonal line on the parallelogram shapes of z1 and z2, that kind of thing. But you don't need to actually worry about that stuff. We are going to cover more on vector later. For now, just be clear on how to plot on Argand diagram. So let's summarize about this lesson. Remember that the real part always should be on the x-axis and the imaginary part should be y-axis. And if you intend to play around with Desmos, remember to use I instead of j. Okay, in the next subtopic, we will learn how to measure the distance and angle of a complex number on this plane. So when I said distance, right, we have z2, let's say, from the origin, and this is the distance, right? This is the distance. And for angle, when I said the angle of complex number, it is the angle from the axis. So for this case, if you want to look at the angle of z2, this is where we will refer to. In degree, of course, right? The angle will be in degree. So that will be in the next subtopic. And when you have the angle and the distance, we will talk about another form that exists that can represent complex number, which is called polar form. Up until now, we are discussing standard form. So the standard form, this is standard form, and another way we have a polar form. Okay, till then, thank you.